Hello, I'm Grant Holden. This is my Chiral Molecule video for organic chemistry, and that's me proving that it's really me, Grant Holden. Today's date is 9/30/2025, and it's 10:40-ish a.m. I'm going to share a picture with you that I have drawn. I've chosen lactic acid as my chiral molecule. Of course, a chiral molecule cannot be superimposed on its mirror image, so it's pretty much a mirror image. But it cannot be overlapped because of the arrangement of the molecules, so it doesn't have that perfect symmetry. So the lactic acid is an organic molecule. The IUPAC name is 2-hydroxypropanoic acid. Of course, you see the composition, the chemical name is C3H6O3. And then a chiral group has a carbon chain that's attached to 4 different groups. So at the bottom, you'll see the 4 groups. It's the hydroxyl group, carboxylic acid group, methyl group, and then of course a hydrogen. To the right in green, there's 2 different enantiomers that lactic acid has: L-lactic acid and D-lactic acid. L-lactic acid on the top right is naturally occurring in the human body and its metabolism, and of course is generally safe. But D-lactic acid, the bottom, could potentially be harmful depending on the level that's accumulated. Of course, higher levels would be more harmful. Lactic acid has some constitutional isomers, including acetic acid, propanoic acid, and glycolic acid. So, let's see. So when assigning, you'll see at the bottom left, this Lewis structure. You'll see that it's got the methyl group to the left, OH group, or the hydroxyl group on the bottom, and then the carboxylic acid group to the right, and it's assigned priorities. The carboxylic acid group is ranked number 1 due to the presence of oxygen in the highest atomic number. The hydroxyl group is next because it has the next highest atomic number. And then, of course, third is the methyl group, and then hydrogen is the least priority. Let's see. So we have the chiral center, and then, of course, the 4 bonded groups. And then I will show you the other one. Oops. So the priority groups, it forms an S-lactic acid because of the priorities in the groups and how they show up or arranged on the atom. So of course it turns into like an S pattern. So you've got 1, 2, 3, 4, which forms an S form. So, and of course, lactic is used in many different ways, including like preservatives in food and flavoring agents. It can help in the fermentation process of yogurts, pickles, and other beverages. It's used in skincare products, drug formulations, and surgical polymers. And of course, probably the most known one in healthcare is, and it's found in anaerobic respiration during cellular metabolism. So, I believe that concludes my video. Thank you for listening.